Good evening, virtual audience, and welcome. Thank you for joining us tonight from wherever in the world you are located. My name is Kate Bruns, and on behalf of Harvard Bookstore, the Harvard University Division of Science, and the Harvard Library, I am so pleased to introduce this event with Christof Koch, discussing his latest book, The Feeling of Life Itself: Why Consciousness is Widespread but Can't Be Computed. Joined in conversation tonight by Gabriel Kramen. Tonight's event is the latest installment in our Harvard Science Book Talk series, which works to bring the authors of recently published science-related literature to our Cambridge community and beyond. Coming up in the series on October 20th, we will virtually welcome James Fleming for a discussion of his new book, First Woman, Joanne Simpson and the Tropical Atmosphere. And then on November 10th, we will host cosmologist John Levin for her latest book, Black Hole Survival Guide. To learn more about this and our other upcoming events, you can sign up for the bookstore's email newsletter at harvard.com or check out the page harvard.com/science for more info. We also have a Science Research Public Lecture Series YouTube page where you can see any previous talks that you might have missed. This evening's event is going to conclude with some time for your questions. If you would like to ask Christof and Gabriel something, please go to the Q&A button at the bottom of your screen where you can submit a question. We're going to get through as many as time allows for this evening. Also, once the event begins, I'm going to post a link in the chat to purchase tonight's featured book, The Feeling of Life Itself. All sales through this link support Harvard Bookstore, so a huge thank you for your support. Your purchases and your financial contributions, there will also be a donate link in the chat, make this virtual author series possible, and now more than ever support the future of a landmark indie bookstore. So thank you so much to our partners at Harvard University, and thank you to all of you for tuning in and showing up for authors, publishers, indie bookselling, and especially for science, because it really matters. And finally, as you might have experienced in virtual gatherings the last few months, technical issues can arise, and if they do, we'll do our best to resolve them quickly. So thank you for your patience and your understanding. And now I am so pleased to introduce tonight's speakers. Physicist turned neurobiologist Christof Koch is the chief scientist and president of the MindScope program at the Allen Institute in Seattle. Best known for his studies exploring the brain basis of consciousness, he's now leading a 10-year large-scale effort to build brain observatories for mapping, analyzing, and understanding the mouse and human cerebral cortex. Prior to the Allen Institute, he was a professor of biology for 27 years at the California Institute of Technology in Pasadena. Christof's also the author of 2 technical textbooks and a previous book, Consciousness: Confessions of a Romantic Reductionist. He's joined on screen tonight by Harvard Medical School and Children's Hospital professor Gabriel Kramen. He leads the Executive Function and Memory module in the Center for Brains, Minds, and Machines, and his lab studies the neuronal circuits and mechanisms underlying perception and cognition. Tonight, the two will be discussing Christof's latest book, The Feeling of Life Itself, just released in paperback this last month and hailed as thorough, witty, and compelling. Nature calls it invigorating. Koch tracks the neural footprints of experience, swims off the wilder shores of integrated information theory, and speculates about the feeling of life itself in ravens, bees, and octopuses. We are so excited to welcome them to your screens tonight. So without further ado, the digital podium is yours, Gabriel and Christof.
Thank you very much, Kate, for the introduction. I don't quite see Christof. He disappeared. Very much, Kate, again. Thanks, everybody, for your patience. I apologize for the technical glitches. So, Christof, it's good to have you back. Why don't we start by you telling us what The Feeling of Life Itself is about?
So here's the book in its paperback edition. The book, The Feeling of Life Itself, is about the feeling of life itself, what I describe every experience. By consciousness, we mean, many of us mean any experience. The way it feels like to be alive, to be sad, to be distraught over the state of the world. Those are all different conscious states. And over the last 50 years, there's been a concerted effort to look at the physical basis of that, called the neuronal correlates of consciousness. to track the footprints of consciousness in the brain of humans and closely related species, to help determine who is conscious, who is not conscious, and to understand the pathologies of consciousness and disorders of consciousness like vegetative states, coma, behavioral unresponsive states. But then there's also the question, how far does consciousness go? Who else has it? And how do we know? And then, of course, there's a question that's confronting us today. Computers that we build ourselves, they are becoming increasingly more intelligent. And what is the relationship between their behavior, intelligent or not, and their ability to feel? Do they feel? Can they ever feel now or in the future? And to answer all those questions, finally, we need a theory. We need a fundamental, rigorous, empirical, accessible theory that tells us sort of from first principles, first in ourselves. It has to be tested in ourselves, because only we are sure, only ultimately I know that I'm conscious. But then in closely related cases like you and my friends and other humans, and ultimately in animals, that tells us who is conscious, who's not conscious, and where does this consciousness, this feeling, this strange feeling, this buzz in the head, the voice in my head, the image in the movie that makes up my life, where this comes from and how does it fit into the picture of the universe that science has given us. So that's what this book is about, particularly with respect to this one theory called integrated information theory. That's one of the two sort of promising candidates of scientific theories of consciousness that people are pursuing today in the lab.
Can you provide a brief summary of the theory of integrated information theory?
Yeah, so IIT, integrated information theory, IIT sort of takes an axiomatic fundamental approach. It says, well, consciousness ultimately is something intrinsic to the system and exists for itself, right? Only I know that I'm conscious, and I may not be able to move. I might be paralyzed. I might be in a state where I'm asleep and my muscles are paralyzed, yet I have conscious experiences. I dream. So ultimately, consciousness is for itself. It's definite. It's highly informative. It's integrated, and and every experience is one. It's a definite experience. There are certain things that are in my experience, and there are certain things that are not a part of my experience. And then from these sort of 5 axioms of what every conscious experience has to obey, these 5 axioms, it then derives postulates about a physical mechanism. So it looks at a physical mechanism, a bunch of neurons or transistors or any other physical state, and then ask, well, what is it about this thing that it has to have in order to be conscious? And the theory ultimately says, what consciousness is sort of intrinsic causal power. It's the way the system is influenced by its past, and the way the system is pregnant, in the words of Leibniz, it's pregnant with its own future. To what extent the system determines its own future. And any system that has a lot of intrinsic causal power, something that you can measure, you can look at the system, you can describe its states. If you know how to go from one state to the other, and you know that exhaustively for all states, you can then in principle determine the full intrinsic causal power of the system. And the theory says ultimately that's what consciousness is. And any one conscious experience, for instance, the conscious experience of spatial extendedness, has to be explainable out of this intrinsic causal power. And so it's a certain system, it measures the causal power system has. This is a number called phi that some of you may have heard. It's a number that's either 0, then the system isn't conscious, the system has no causal power upon itself. The system, strictly speaking, doesn't exist for itself because it can be explained as an independent sum of individual components, so therefore it doesn't exist as a system. But any system that exists for itself has a number phi that's bigger than 0, and the bigger the number phi, the more conscious the system is. So in principle, the theory gives rise to this measure of consciousness that you can apply to babies and to fetuses and to normal adults and to stroke victims and to cats and mice and dogs and worms. And in principle, you can sort of take this phi meter and measure the amount of intrinsic causal power the system has, thereby how conscious that particular system is in a particular state.
So this sounds really fascinating. And to me, one of the most counterintuitive aspects of this theory is exactly what you were just alluding to, this 5 meter. The notion that we might be able to measure phi in all kinds of things, from flies to bacteria to chairs and tables and computers. Some of these may have a very low phi, but a non-zero phi. So how do you reconcile, or how do you think about the notion that bacteria may have a low degree of phi, or that my iPhone may have a low phi value? And what does this number, what does having a higher phi value or a lower value mean?
Well, so it means to what extent is the system irreducible? I mean, ultimately, it's one number. It doesn't quantify, it doesn't sort of describe the qualitative aspect of the particular conscious state the brain is. So let's say my phi might be 6.8 times 10 to the 25. That's a high number, but it doesn't tell you, am I, conscious of pain or red or of the state of the affair, right? So for that, you have to read out the individual component of the system. But it tells you at least this is a system that's highly integrated, highly differentiated, and therefore has this intrinsic causal power, is conscious. And it violates, because as you said, it may be true that even simple systems like flies, like worms, the worm C. elegans that's studied widely in the lab, or maybe even individual bacteria may have, because they're so vastly complex. Today, we cannot even on a supercomputer model all the molecular interaction within a single cell. So it may well be that even this itsy bitsy tiny cell has some measure of phi that's different from zero. So that violates our intuition, because we think, well, only you and I, and maybe cats and dogs and great apes, and elephants and other charismatic megafauna are conscious. But of course, here I'm not talking about high degree of consciousness. We're not talking about mental content like you and I, right? If it's true that a bacteria has a phi, let's say, of 25 for the sake of argument, or 42, it's a nicer number, 42, right? That doesn't mean the bacteria has thoughts about tomorrow, or has regrets, or feels fat, or feels, it just may feel like something. And when it's dead, when it's dissolved into its component, it doesn't feel like anything. So it may be, it will be a very primitive form, but it may well be that this feeling, again, of life itself may persist even in a simple organism that most people assume, for heaven's sake, they can't be conscious. Just like, many other measures in the universe, like temperature. We know out in outer space, there's actually temperature different from absolute zero, right? It's 4.2 degrees, it's a background radiation. It's incredible cold in outer space, yet physics and measurement tell us there's still a minimum amount of molecular motion that can be measured as temperature in deep space. And so it may be with this measure phi. And this is, of course, a very ancient philosophical belief. Some of the greatest thinkers in the West, Plato, Schopenhauer, Russell, Leibniz, one of the fathers of computers and integral calculus, all thought that consciousness is far more widespread than we are led to believe.
One aspect that's fascinating that you touch upon in the book is the connection between consciousness and intelligence, or the lack of connection between the two. There are many movies out there about the idea that we may have sentient machines. You even wrote a beautiful article about the movie Ex Machina. You have argued quite vehemently that intelligence and consciousness are quite different things. So can you expand on that?
Intelligence ultimately is a measure of behavior. It's if I'm confronted with some particular new environment, how quickly do you adapt to it, over immediate or over short term or over the long term, right? So that ultimately is intelligence, the way to rapidly adapt, modulate my behavior appropriate to the circumstance. That's all behavior. That doesn't say anything about feeling. That doesn't say anything about experience. So conceptually, intelligence and experience are really very different things. Now, in humans, or maybe in all evolved creatures such as other animals, intelligence and consciousness may well correlate. In fact, in our brain, they may well commingle, but conceptually they're different. And you can certainly imagine a supercomputer that is as intelligent as us, or that's even, superhuman artificial general intelligence, but that has no feeling whatsoever. Conversely, you can easily imagine brain organoids that we can now engineer or at least in 10 or 20 years in large sort of carpets of cortical, engineered from human inducible pluripotent stem cells that give rise to a large carpet of cerebral organoids that have high consciousness yet no behavior because they have no output effectors. So you can certainly, the way I think about them is a plane, and on the x-axis you plot the intelligence of that individual or of that species, and on the y-axis you plot the measure of consciousness that the species or the individual of that species has. And in principle, these are independent things. In fact, so integrated information theory predicts that digital computers of the sort von Neumann machine we have today have very small intrinsic causal power. And although in their aggregate, they can simulate the human brain, or they can in principle simulate intelligent behavior, and they probably will do that soon in the future, it doesn't feel like anything to be such a digital simulation, even of a human brain. Just like you can simulate the causal power of gravity, for example, of the black hole at the center of our galaxy, right? Sagittarius A star, the Nobel Prizes were given out for that last week. We can write a computer program that simulates the power of the black hole to attract everything to it, so nothing can escape, not even light. That's the name. But funny, we don't have to be concerned that the computer programmer himself or herself will be sucked into the computer simulation. Why not? Well, that's a difference between the real and the simulated. The simulated doesn't have the causal power of the real. And because it doesn't have the causal power, you won't get the gravitational singularity. Likewise, you can simulate behavior, but you will not get the consciousness associated with the behavior unless you replicate the human brain in particular hardware.
So despite this dissociation, in your book, you also argue that in principle, there is no physical limit to consciousness, in the sense that we might, in principle, with a different type of hardware, and you alluded to neuromorphic engineering, for example, we might be able to build devices that would have a high phi.
That's correct. There's nothing supernatural about the human brain. It doesn't have extra magical properties that other, the human brain is part and parcel of the universe. It's a piece of furniture of the universe subject to the same laws of quantum mechanics and general relativity as everything else. So in that sense, there's nothing supernatural. It is true, IoT has no natural limit on phi. Phi can be big. In fact, we might be able to artificially enhance enlarge our brain by connecting to brains. So just like, we know that if I take a normal brain and I cut it in two to prevent epileptic seizures from spreading from one cortical hemisphere into the other one, it's called a split brain procedure, I can do the inverse. I can take two brains, let's say your brain and my brain, and with a future yet to be invented technology I call brain bridging, where we directly connect my neurons, my cortical neurons with your cortical neurons, sort of like an artificial corpus callosum. We would then, according to the theory, if we add more and more wires, at some point we would abruptly get a new conscious entity that would have aspect of your brain and my brain. It would be some sort of amalgamation of Gabriel and Christof. It would control, two mouths, and it would, have 4 arms and 4 legs, and its phi would presumably considerably higher than the phi of either you or I. Brain bridging, try it. We should try it as soon as we can. First be able to do it in mice.
Like the creatures in Flatland who cannot imagine other dimensions, I find it hard to even conceive what it would mean to have a higher phi. Imagine either by merging two brains or by some sort of device that you can implant in your brain, or by training or any other mechanism. Imagine that you can duplicate phi. What would that mean? What would that feel like? What would be the feeling of life itself be with a higher phi?
Well, I mean, just cast your mind back when you were, before, let's say, you knew about sex, or before the first time you fell in love, right? There's this entire new universe, when you discover sexuality and you find and express your own sexuality, you now become sort of more conscious, right? You become conscious of whoever attracts you, and that gives rise to a universe of conscious states. You fall in love, right? It's a profound new conscious state that, presumably 7 or 8 or 9 or 10-year-olds you didn't have. The first time you drank alcohol, the first time you tried, if you ever did, psilocybin or 5-MeO or any other drugs, the first time you drank wine, right? So these are all, from our own experiences, we know to a certain extent what it means to have new conscious experiences. And so likewise, you just extrapolate that, to a merged brain when we have new states accessible that neither your brain or my brain by itself will be conscious of. It won't be dramatic different because you're still a human brain and I'm still a human brain. But there will be new states that we cannot have experienced before.
Can I switch gears now to a more personal level? You end the book on a passionate argument about how studying consciousness has changed aspects of your life, or how you see the world, or how we as humans interact with the world in general. What do you think are the implications of getting further and further into the mechanisms of consciousness for you, for society, for our lives?
Well, that you realize how very precious it is, how we would be nothing to ourselves if we wouldn't be conscious. Without consciousness, we don't exist for ourselves, right? If I'm a perfect zombie that moves around the world, that looks and behaves like me and does everything, if you give me $1 billion, but I say I'm going to take away your experience, well, what's the point? Then, I'm no one to myself. I don't exist. I may as well not exist for myself. So you just realize the preciousness of experience and how it is unique above anything else. And also you realize, particularly when you study consciousness in other animals, be that closely related species like dogs, or be that more distant like an octopus, that consciousness and the pains and pleasures of life, they're widespread, and we should respect them even in insects. So, since I had this sort of conversion to a more broader view of consciousness, I don't eat flesh of animals anymore. I don't even kill insects anymore, because they too have this brief moment, bookended between two eternity, this brief moment when they can exist and when they have feelings. And so once again, it makes life all the more precious.
Thank you. Thanks. That's quite beautiful. Again, sort of on a personal level, the question of consciousness has always elicited very strong reactions from scientists, philosophers, many people who have argued that we're not quite ready to tackle this question. Many people who have argued that these questions are unanswerable. How do you have the courage to drive the field forward? How do you manage in the midst of so many different opinions and skepticism and other ways of thinking about the problem?
Well, you disregard much of that. Of course, it's self-fulfilling prophecy. If you say we can never tackle it, then of course, by definition, we'll never solve it. So, we have to do the best we can. Yes, maybe I'm deluding myself in the theory, this idea I'm pursuing won't be the correct final theory, but the most important thing, it makes very specific predictions. We're now engaged in this adversarial collaboration. In fact, you, Gabriel, of course, are part of that, where we test prediction of the two dominant theories of consciousness, the dominant scientific theories, integrated information theory and global neuronal workspace. And so again, in that sort of clash of ideas and specific experiment, even if both theories will shown to be very imperfect approximation, that's progress, right? And on this ancient 2,400-year-old, at least, old problem, we can make progress. So for instance, IT has already now provided progress. There's now a procedure that's used in several hundred patients already, that's being tested in many clinics, called ZAP and ZIP, to actually test whether this patient who's unresponsive, right, who I cannot communicate with because her brain is so damaged due to traffic accident and whatever, I can now test, using this calculus whether whether somebody home there or not. So that shows that real progress is possible despite the doomsayers and despite many people saying, well, it's philosophy. Of course it's philosophy. It's one of the oldest problems of philosophy, but all scientific problems started off as philosophy early on. And then as we developed powerful tools and theories, we took them from philosophy and turned them into empirical science.
Very good. I'm going to turn it now to the audience. There's a lot of questions in the Q&A. So I'm going to read some of the questions. There are two people here, Swami and Glenn, that are asking about where do you stand on the hard problem of consciousness? Is the hard problem of consciousness answerable?
Well, once again, I mean, if you believe the hard problem of David Chalmers that it is forever hard, then of course you're never going to try to solve it. So once again, I find that a defeatist argument. Many philosophers over the last 100 years have made often the argument that certain problems can never be solved, will never be accessible to human insight. Like, for example, Auguste Comte in the 19th century, the father of positivism, made this assertion, we shall never know what stars are made out of. Today, he probably would have said, well, that's a hard problem with a capital H. Well, it turned out 20 years later, they invented the spectrogram, and you could analyze the constituents in the atmosphere of our own sun by looking at the spectral decomposition. So yes, these problems are difficult, but are they forever hard? We don't know. Human ingenuity is very powerful. So let's trust our good old ingenuity to solve these problems. Let's not be taking in too much.
I agree, absolutely. David Ryson asks about the functions of dreams, and I assume the relationship between dreams and consciousness.
Dreams, so the function of dreams, there are many hypotheses about it. Francis Crick, of course, had the famous one. It's used to more efficiently reorganize our memories. We still don't know what the function of dreams is, if it has one, but certainly dreaming is one part of consciousness. It is conscious, you're highly conscious of it, you see and hear. In fact, inside the dream, you cannot typically distinguish the dream from reality, right? Most people, except if you have a lucid dream, you don't know that you're in a dream. And you're not surprised that you can walk through walls or fly or meet, a long lost pet or long lost loved one. So it's another manifestation of consciousness inside a sleeping body. So it makes it particularly interesting to study.
I apologize to the audience if I don't get to all the questions or if I mispronounce your names. Peter Cariani asks, how does Tononi's theory of requisite informational complexity of accessible functional states relate to neural global workspace theories that requires closure via sustained regenerative recurrent activity and feedback? So it's the relationship between IIT and complexity and Victor Lame, Bernard Bars, Dehaene, and global workspace theories.
Okay, well, okay, there are 4 different theories. So IIT is being tested right now in this international collaboration with 10 different labs, Gabriel Kreimann here being one of them, where some of the prediction of IIT are contrasted against the prediction of global neural workspace. It's very difficult right now because global neural workspace makes very different assumptions about consciousness than IIT, and has different implications for computer consciousness. Right now, those can be tested, but what we can, some of the neuronal implications. Global neural workspace has consciousness, the footprint of consciousness essentially in the front of the brain because it has to do with cognition, with intelligence. IIT essentially says nodes in the back of the brain, the back of cortex, where the connectivity is highest. So that's a big, for instance, that we're trying to test. The 2 theories also differ on on the relationship between the timing of the footprint of consciousness and how long you're conscious of something. Again, that can be tested, and that is being tested right now in this 3-year-long effort. So we will know in 2 years or so, or 3 years maybe, given COVID, we'll know more about the status of GNW versus IIT.
Changyan Lingu, and again, I apologize if I'm mispronouncing your name, consciousness is something confused with awareness and or attention by the general public. Are these terms related in some way, or are they totally separated concepts? So consciousness, awareness, attention.
Okay, it's a very good question. So some people distinguish between awareness and consciousness. I've never found any useful operational way. So for me, it's the same. I just noticed sociologically, most people are more comfortable speaking about awareness, for example, in grants rather than consciousness. But scientifically, I don't distinguish. Attention and consciousness are very different. So, and we now know experimentally, there are probably 60, 70 different experiments where people have shown that you can attend to something, attention visual in this case, but not be conscious of it, which sounds strange, right? So attention means selective processing of information, selective in space, in time, or in some feature. You can do that without being conscious. So at least you can dissociate attention and conscious one way. Whether you can dissociate both ways, that in other words, can you be conscious of something without attending to it, that remains experimentally more difficult to address. And that remains much more controversial. But I think most psychologists would now agree that you can attend to things without necessarily becoming conscious of them.
So in your book, you touch upon meditation as well as states of consciousness devoid of any external sensory experience. An anonymous attendee asks, Hare Krishna chanting or bhakti yoga is said to evolve one's consciousness. So meditation, yoga, certain practices that are purported to evolve consciousness. Can I know your take on this?
Yeah, so I don't know personally because I'm not a practitioner of these particular meditative or practices. There are this class of experience called mystical experiences that you can get in certain forms of meditation. And some people call it naked awareness or sheer awareness, pure awareness it's called. Some people also report these doing in an isolation tank, these mystical experiences. Of course, the world literature is full of them with respect to religious conversion experiences. They also have some of this character. Near-death experiences sometimes have this character. And certain drugs, particularly the drugs of the serotonin class like psilocybin, DMT, and 5-MeO DMT can also lead to these mystical states. So what's a mystical state? So from a phenomenological point of view, a mystical state is a state when two things totally disappear, the self and time. So typically, and I've been in these states, you're gone, your memory's gone, your thoughts are gone, the self is gone, your body's gone, there's no more Christof, no more thoughts, no more dreams, no more desire, none of that is present. They're timeless, they're not too short, they're not too long, there's no flow of time. So the sense of self is completely gone, the sense of time is totally gone. Sometimes the sense of space can be gone. And typically, you don't hear, you don't see, you don't have fear, you don't have pain, you don't have pleasure. Typically, they're associated with very powerful emotional states, either ecstasy or dread or a curious combination. So in some of my mystical experiences, you have this combination of awfulness, sort of the awfulness of pure experience, the ecstasy and the terror of being confronted with this, what feels like a pure thing. And there's no more you there. It's a very peculiar state. It's very, very compelling. But I think ultimately it is a product of the brain. I'm not sure whether I would call it higher consciousness. It's a very rarely encountered form of consciousness. I'm not sure to what extent it is a higher form of consciousness.
You just alluded to memory. Javier Macis asks, does consciousness require a capacity for memory, at least short-term memory?
Probably yes. Although IET doesn't say, the theory doesn't say anything specific about memory, certainly for human level, it's very difficult to imagine being conscious without at least having very short-term memory. And I know no patient that doesn't have, of course, there are plenty of patients who've lost long-term memory, yet are still conscious, like, people with dementia, they're clearly conscious, but don't even know who they are anymore. It's very difficult to imagine what would it be like to have to not even have this short-term form of consciousness. In principle, though, it may be possible.
With several others, Kirill Sinkel asks whether there is a function to consciousness. And I know in the book you talk about the evolution of consciousness as well.
Yeah, so that's a very, very good one, because we have to ask, I mean, we clearly are highly conscious, and I can be, I think you get older, you can be conscious of your internal states, and it's highly differentiated. So clearly this couldn't have arisen by chance. So what is the function of consciousness? And there have been many, many functions that have been proposed, including by myself and Francis Crick. So for instance, to make my particular idea is executive hypothesis. I live in a very complex environment. If I want to quickly summarize what goes on and make that summary available to my planning stages, like an executive summary, that could be one function. Neurology, it's very often very difficult to answer the function. What's the function of one leg or one eye or of one gene? Those are very difficult to answer. And the way I think about consciousness and evolution is, per IIT, consciousness by itself doesn't have a function. It's just its internal causal power. Just like no physicist would say, well, what's the function of electric charge, or what's the function of gravity? Gravity is just, space, it's curvature in space-time. Electric charge is just the propensity of things to attract or to repel each other. Now, biological organism can exploit electric charge, right? For example, to separate charges inside and outside a neuron, and you get a neuronal, you get a membrane potential and an action potential, but primarily it doesn't have a function. Behavior, evolution selects for behavior, right? Evolution ultimately selects whether I'm going to survive or not what I feel inside. So it's from a point of view of evolution, you could argue that consciousness directly is like what Dawkins or Wilson at Harvard calls a spandrel. It's not directly selected for. What's directly selected for by evolution is behavior. But indirectly, you can show this very nice in computer simulation. When you have creatures that you evolve in artificial environments, the creatures do better to the extent they take all their sensors and integrate them and make all that integrated information available to their processor. Right? Their sound and their sight, their camera and everything goes into the central processor to make that information available to planning. And you can measure in these simulated creatures that they also have high phi. So you would expect evolutionary that systems evolve that have high adaptability and high intelligence also have high phi, which is why intelligence and I think phi correlate in evolved creatures. But in engineered system, like on the one hand brain organoids, on the other hand artificial, supercomputers, I think you can separate that and you can build systems that have high intelligence and no consciousness, or that may even have high consciousness but no intelligence.
So an anonymous attendee asks whether you think it's ethical to induce consciousness in machines. So you talked a little bit about the fact that today's machines don't quite have it per IIT. But what if future machines built on different hardware could actually have hi-fi and therefore, according to a theory, consciousness? Do you foresee any ethical problems with building machines that are sentient?
Well, I mean, you can look at Black Mirror, you can look at Westworld, there will be untold, it's a complex world, and you can imagine all sorts of nasty scenarios where you build something that only experiences pain, that's in fact only capable of experiencing pain, and that would be, of course, atrocious to put such a creature into the world. You can also imagine that you can build creatures that only experience pleasure, or more likely, if these creatures actually have to survive out there, that have, like us, that can experience both pain and pleasures. And then I think the moral imperative is to enable them to live in a universe where they maximize, the pleasure, or they maximize their own capability to experience, and you minimize the pain. But in practice, there will always be scenarios where this doesn't happen, or where you get these conflicts, as you can see in watching Westworld episodes.
If it's okay with you, Christof, we'll take a few more questions. Is that okay?
Yeah.
Murtaza asks, is intentionality a property of consciousness? I assume this is talking about the relationship between consciousness and volition and free will and intentionality. Are these things related?
Well, yeah. So consciousness always has content. It's always about something, right? So it's about my toothache, or it's about, seeing Gabriel here on the screen. As I said, it may be possible in states of pure consciousness when there is no more content. And then the question is, then there isn't really any intentionality anymore, because it's not about anything. If it's really true that you can truly obtain a state of pure consciousness with no content whatsoever. Free will is a totally separate question. So according having will, having the feeling of will, of agency, I'm now raising my left hand and now I'm raising my right hand. That goes hand in hand with ownership. I know it's my hand, it's not Gabriel's hand. And it goes hand with a feeling of intentionality. I wanted to raise my right hand, or I wanted to raise my left hand. And the feeling of wanting to do it, as compared to when you put a transcranial magnetic stimulation on my head and trigger it, then I feel my hand flip. But I know it's not me that triggered that, and that's a very different feeling. So these are all conscious feelings that go hand in hand with consciousness. IIT says will, what people call will, essentially is a maximum of causal power. The maximum of intrinsic causal power, that's it, what you experience as a feeling of agency that we all have.
The maximal causal power is also important to understand in terms of two other questions that are here that I'm going to put together. One question relates to what do you think about Marvin Minsky's Society of Mind? And the other question relates to consciousness at different levels. For example, does a society as a whole have consciousness?
Okay, so that relates to the general question, the mereological question of the relationship between the parts and the whole. So IIT says it's only the maximum for any particular substrate that's conscious. So right now, Gabriel is conscious, I'm conscious. We interact. So clearly there's some sort of amount of interaction among the two of us. But if we compute the integrated information across both Gabriel's and my brains, it's minuscule. So there isn't any entity that exists that is Gabriel and Christof. Likewise, if I extend this over all 310 million Americans, that is a tiny it's a tiny number, vastly less than the number inside my head or the head of any other American. Therefore, America does not exist as an intrinsic, as a maximum of causal effect power. Therefore, there isn't anything like it to be America as a conscious entity. Although America, of course, has external causal powers, it can start wars, etc., but it doesn't have any intrinsic causal power. So it's really only the maximum. So likewise, the neurons in my head, the individual neurons aren't conscious. It's really the collective, the maximum of whatever in the footprint in my brain that's constituted by the maximum at that level of resolution is what conscious, not the individual neurons, not the individual atoms that make part of it. And that's true whether you're dealing with society or with brains, or with subcomponents of brains. It's always only the maximum.
Very good. So there's a question here. Maybe I'll take one more question if that's okay with you, Christof. I know we're running a little bit after 6 in Boston. There are two questions here by Sechen Sang. Does current research in learning theory from both neuroscience and machine learning community help us in any way to understand consciousness?
It helps us practically, for sure. So, at the institute I run here, the Allen Institute for Brain Science, we use all sorts of advanced machine learning, deep interpolation, other advanced machine learning techniques to help us make sense of the data. Will it help us conceptually to understand it? I don't know at this point. I can't answer that. I haven't seen that directly, but I don't exclude it. All right.
Very good. Thank you very much, Christof. This was really wonderful. I'm glad that you're surviving the windstorm and that you managed to connect with us. And It's been a pleasure talking to you about the feeling of life itself, which I truly enjoyed. So thanks a lot.
Thanks a lot. Thanks a lot, Kate, for hosting us.
I was going to say, if you have time and you'd like to, you're more than welcome to go 10 minutes over, because I know that we started late. But if you have somewhere to go, no problem.
Yeah, I have my next Zoom call coming up.